Good morning. I have another problem for you today. We've got the boom at 30 degrees, but we have 3 bricks for the load. Got to figure out how much counterweight and where to put it. So go back to video number 3, the one before this, and you'll remember how we do it. So first we got to find the torque of the load. I think the first video will tell you the weight of 1 brick, so now you got 3. Well, by the way, you got to do all the work. Get out a paper and pencil and start writing everything down. Show your work, show how you came up with things like the distance is 30 inches for the load. From the last video, you'll remember. So write it down and show how we determined that this distance was 30 inches. So weight times distance is torque. 30 inches times whatever the weight is gives you the torque of the load. Then we have to add the torque of the boom. And that we figured out from the last video was 22 foot-pounds. Inch pounds. Combine those two, that's the combined torque of the load and the boom. And don't forget, the safety factor, if this is, let's say, 100 inch-pounds, the crane body has to be 150, a factor of 1.5 to prevent it from tipping over. So whatever you get, whatever this number is, multiplied by 1.5, the safety factor, that tells you how much torque is required of the crane body. Now the crane body itself is 174.25. That's with no counterweight, just the body itself. So we need, let's say 600 foot-pounds. Number 3, when we multiply, let's say we get 600 foot-pounds. It's not, but let's say 600 foot-pounds. We subtract the 174 of the weight of the crane body, and that, whatever number is left, that's the required extra torque, extra counterweight we need. Let's call it theta, another Greek letter. Remember that, we'll be using that a lot in other videos. So theta is weight times distance. We don't know the weight yet, but I've said it's going to be 24 inches from the pivot point. Why? Because, make it a little more interesting. So the weight is going to be here, 24 inches from the pivot point. So first, when you do run the numbers, you'll find out what it's going to be. But I'll give you a hint. This is solid steel. This is part of a pulley, hook, railroad spike. That's what you're going to need, but how many pounds it is, you're going to have to figure that out. So, let's see if it's going to work. Three bricks, 30 inches away from the pivot point. What do you think? Pretty stable? So you figure out what this weight is. It's going to be 24 inches from the pivot point. And I'll have some more problems for you next time.